Hello, my name is Stefan de Velde. I'm a professor of operations management at the Rotterdam School of Management, and I'm going to present today a totally new perspective on supply chain decision making, which might help you in the FreshConnect game. Already 20 years ago, three gurus from the Harvard Business School, Mr. Hayes, Wheelwright and Clark, already pointed out that a competitive advantage typically comes from people, and mainly their ability to solve problems and their capacity for learning. Well, this raises the question, how good are people in solving problems? In the FreshConnect game, you need to solve many problems and make many decisions. Well, the traditional assumptions in supply chain are that decision makers are rational or can be induced to behave rationally. And another big assumption is that decision makers are optimizers. And then also in supply chain management, the dominant paradigm is formal mathematical modeling. Briefly, you can say, well, give me the model, I put it into a decision support system or an advanced planning or scheduling system, and the model will give you the optimal solution, and it will tell you what you need to do. But are we truly rational? Are we really optimizers? And very often asking the question is already answering it. There's an important phenomenon in management, and that's called bounded rationality. What does it mean? Well, bounded rationality says that our rationality is bounded by a number of factors. For instance, lack of information or lack of data. If we don't have sufficient data, if we don't have sufficient information, it's very hard to stay rational, to find an optimal solution. Another factor that may hamper our rationality is the limited amount of time to reach an optimal solution. If there is a lot of time pressure, then again, we fail to find an optimal solution. But the third factor may be the most daunting of all, and that's cognitive limitations. Even if we have enough time, and even if we have all the information and data available, then in many cases, still, we fail to find an optimal solution. This happens in practice a lot. So what do we do typically? Well, we use what we call heuristics. We tend to simplify the problem and use mental shortcuts, rules of thumb, to find an acceptable solution or a feasible solution. And in many cases, this works just fine. Well, the area of behavioral supply chain management is not focusing on questions like how should you solve a problem or how should you think about a problem. It's not normative, but it is descriptive. It asks questions like how are people making decisions and how are they solving particular problems. In the news vendor problem, you need to balance the cost of a stock out, that is, lost sales, against the cost of overstocking. And while the problem itself doesn't appear that often in practice, the insight that it generates are relevant not only for supply chain management, but also production management, revenue management, and capital investment decisions. So what is the problem about? Well, suppose you're selling newspapers on the corner of the street, day after day, week after week, year after year. And by doing this, you have a very good understanding of market demand. Demand is not fixed, it's random, but you know, for instance, that demand is uniformly distributed on the interval between 0 and some big D. What does it mean? Well, it's like spinning a wheel, and on the wheel you have all the numbers between 0 and a big D, and every number has exactly the same probability of coming up. Well, what else? Well, suppose you have the opportunity of buying newspapers in the morning for a purchasing price C per unit. And suppose you can sell those newspapers against the price P per unit later that particular day. And of course we assume that the selling price is strictly bigger than the purchasing price. Well, since we're selling newspapers, and if you have any newspapers left at the end of the day, there's nothing that you can do with them except throwing them away. So it means there is no residual value. Well, given this particular setting, the question is how many newspapers to buy in the morning so as to maximize your expected profit. So note, we're talking here about what's called a single period model. Whatever you do in this particular period, whatever you buy, can't be sold tomorrow. To make it more concrete, I have here exactly the same description, but I'm now using particular data. So I'm saying demand is uniformly distributed between 0 and 100. The purchasing price is 1 and the selling price is 4. Again, how many newspapers would you want to buy in order to maximize expected profit? And I'm giving you maybe 5 or 10 seconds to make up your mind. How many newspapers would you buy? Well, thinking about this issue, probably you realize that you have to make a trade-off between the probability of having too much and the probability of having too little. If you have too much, then you have to scrap all the papers that you have left. And if you have too little, basically you leave money on the table and you have lost sales. Well, the thing is that mathematically, this problem is very well understood. And very well understood means we know how to solve it. We know what the optimal order quantity is. Mathematically, you can prove that if demand is uniformly distributed, the optimal order quantity is, and now I'm becoming a little bit technical, is big D, which is maximum demand, times P minus C divided by P. And please note that P minus C over P is the margin of your product. So basically what I'm saying here is that the larger the margin, the more you should buy. And the bigger the maximum demand, the more you should buy, right? So if you keep this formula in mind, how would it work in this particular example? Well, we had the selling price was 4, the purchasing price was 1, so we're talking about high margin products, and then the optimal order quantity would be 75. Suppose now that we had different parameters like P is 4 and C is 2, in which case I call them average margin products. The optimal order quantity would be 50. But the question is, are people actually doing this? Would they do this in a laboratory setting? And by a laboratory, I mean a controlled experiment in which you give the task of setting the expected profit maximizing quantity to a number of participants. Will they choose the optimal order quantity? What I present here are the results of such an experiment. Let me explain to you what this all means. What you see here is the average order quantity of quite a big group of participants who had to decide on the order quantity in 30 consecutive rounds. So in every round, they were given this particular task. What's the optimal order quantity? You can also see that there are actually 3 treatments. So one group was given the task with high margin products, C is 1. One group was given the task with average margin products, C is 2. And one group was given the task with low margin products, C is 3. So how would it work? Well, in your first round, you set a certain order quantity, say 60. Then you hear or you're told that actually you sold only 50. and you had maybe 10 left, right? Then again, you're asked the question, how much do you want to order? And then maybe you order exactly the same amount, or you adjust it, you order more or less, and so on and so on. And you do this for 30 rounds in a row. I'll now give you some time to have a good look at this chart. What is it saying to you? What's happening here? Well, an important observation is that typically for the average margin product, that is the product with CS2, the participants stay pretty close to the optimal solution. However, for the high margin product and for the low margin product, they significantly deviate from the optimal solution. Specifically, they are overstocking the low margin product and understocking the high margin product. And then the question is, why is this so? Why do we see these systematic deviations? So remember that participants are typically overstocking the low margin products and understocking the high margin products, right? What would be the anchoring? Well, a possible explanation for this is that participants, the decision makers, are anchoring on the expected demand. Remember that demand was uniformly distributed between 0 and 100. So you expect to sell 50 units on average, right? So if you overstock, if you stock more than 50, you expect to have too much. If you understock, you expect to have too little. And it seems like the 50 is an anchor that draws the order quantity that decision makers set to itself. But there might be additional explanations why people deviate from the optimal solution for high margin and low margin products. For the low margin products, it might well be that there is what we call a stockout bias. The stockout bias means that people simply hate to sell no. They don't want to have a stockout. Although for low margin products, it's totally rational to have one. For high margin products, it might well be that a regret bias is playing out. A regret bias means the following. Remember that for high margin products, you need to overstock. You need to buy 75 units, which means that typically you will have too much, right? How will people perceive this? Well, they will see it as a loss. They will see it as a regret, right? You invested in this inventory, it has costed you money, but then you have to scrap it. You lose money. So that's a regret, and that might explain why people are understocking high margin products. Biases that affect our decision making in general, but also in supply chain management. And they can be classified into 3 categories. All the biases that impact in the way we acquire information, the way we process information, and the way we handle cognitive biases. You also have what we call motivational biases. And that's the last bias I would like to point out to you. Higgins in 1997 developed a new theory called self-regulatory focus. And he says that people basically have 2 motivational strategies. One is promotion and one is prevention. People with a promotion focus are mainly focused on obtaining success. Basically, they see the outcome of any event in terms of success versus non-success. People with a prevention focus are focused on security, safety, and responsibility. And basically, they see the outcome of any event in terms of failure versus non-failure. And typically, people with a promotion focus are trying to achieve success, and people with a prevention focus are trying to avoid failure. It turns out that people with a promotion focus have the tendency to overstock in the newsboy problem. And it also turns out that people with a prevention focus have the tendency to understock. So there are all these biases that may affect your decision making. And the best protection against it is to be aware of them. However, up to now, I've talked about how all these biases affect our decision making as an individual, at the individual level. But how does it work in teams? Because remember, in the FreshConnect game, you work as a team of 4 people. Are these biases still very prevalent? Or is it that in teams you have that the sum is more of the parts? Or is it that in a team you are much more bound to fail? Well, research has shown that actually the tendency for biases tend to be exaggerated in teams rather than mitigated. And that's probably counterintuitive. Most people would expect that in teams, all these biases that people have, that they would be balanced out. But that's not true. You have something that's called risky shift. However, there's something that you can do against it, and that's called reflexivity. Reflexivity is a very important mechanism to counter biases. It's defined as the extent by which teams collectively reflect on the goals, the strategies, and the processes for decision making. It's not so much how they make decisions per se, it's the way the procedure to make decisions. And if you do this right, then you can steer away from all these biases and all these errors that individuals tend to make. How does this all work out in the FreshConnect game? Well, we did some research on it last year, and we researched to what extent the reflexivity and regulatory focus, so whether or not a group of people have a promotion focus or a prevention focus, to what extent these 2 important factors predict the success of a team in the FreshConnect game. And it turns out, and these results are very compelling, that a certain combination really is conducive for getting very high results in the FreshConnect game. So what you see here in this particular chart is a summary of our results. There are 2 axes, reflexivity and return on investment. And note that one particular type of team really outperforms all other teams. And these are the teams that are high on reflexivity, so that are really thinking about the way they make decisions, and that have a low promotion focus and a high prevention focus. Again, that might be counterintuitive because typically most people would think that a promotion focus would be better. These results are contradicting that intuition. So to wrap this chart up once more, high reflexivity, a low promotion focus, and a high prevention focus will really help you to play this game better. So it's like Kahneman said, and Kahneman won a Nobel Prize for actually researching all these biases in economics. He said that the odds of defeating biases in a group setting rise when discussion of them is widespread. Hence the need for a language to discuss biases, that familiarity, the awareness is conducive to counteracting them, that some general principles may provide further help, including reflexivity. And this is my last slide. And hence, I wish you all the best playing the Fresh Connection game. Thank you.